Jumpin' JSON Swifters, it's Prof G, and in this lesson we're going to work through two common problems when dealing with API calls. First, we'll see how you can make parsed JSON conform to identifiable so we can include an ID property while silencing a common warning. Then, we'll also see how sometimes a JSON key might be a string that isn't a valid SwiftUI variable name, thwarting our attempts to decode JSON. But we'll learn ways around both of these challenges by working with SwiftUI's CodingKeys. We're also going to learn to work with AsyncImage phases, offering different views if we have a valid image, if an image is loading, and we'll switch to a progress view for that, or if no image is available. And by the time we're done, we'll also be getting an even higher quality image that's available for nearly every one of the 1,000+ creatures that the user might click on. Let's learn big! Now, so far we've been working through our listed JSON by iterating through a range using an index and setting the ID property required by list iteration by using \self. But there might be some situations where you don't want to do this. One example would be if we have more than one Pokemon with the same name. Now, this isn't a concern for us here, but it is a good idea that we know how to deal with that situation. Now, we can fix that issue by setting a data structure to identifiable. Now, when we do that, SwiftUI will require us to create a property name, ID, that contains a unique value, and SwiftUI will use that property, that ID value, to identify one element from another. Now, Americans might think about this as being like a social security number. Even if two people have the same name, the social security number is unique, and it can tell one person from the other. Same with the ID property. Now, we're going to make our creature structure identifiable, and once we do that, each creature in creatures array will have a unique attribute. So another advantage is we can get rid of this ID property. We no longer need that when we want to iterate through an array, when we use something like a list or for each. So let's head over to creature file and let's make our creature struct identifiable. And identifiable also conforms to hashable. So I'm going to highlight hashable and replace that with identifiable. But when I do this, Xcode will complain that we don't conform to the identifiable protocol, but it'll offer to add stubs for conformance. I'll click Fix. Okay, Xcode, stub me. And in this case, it just includes a variable named ID, lowercase I, lowercase d. That's what identifiable requires. Now I'm going to make a few changes to this. One is that I'm going to change the variable to a constant by switching var to let. And I'm doing this because I'm going to initialize the ID property with a unique value that should never be changed. So to do this, I'm also going to highlight and delete the colon through the object identifier. That's actually not important to us, but we'll use a technique for creating unique values for this property whenever we create a new creature. We're going to do that by setting this equal to UUID, open and close parens, and this will create a universally unique identifier. And by pressing dot, we can see a bunch of techniques for creating this. I'm going to select UUID string, lower camel case. I like using a string because it's easy to print out if we ever need to see the value. And if you're curious, this will create a unique value of 128 bits in size. This is a value that's got 36 zeros behind it. For you number geeks, that's called a unidecillion, and you can trust it to be pretty unique. Now this will actually work. Our code will run, but we do get this annoying warning that we see highlighted in yellow. This essentially says we can't decode into the ID property because it's immutable. Now I know I can't decode into this constant. I'm not going to try to do this, so this warning doesn't mean anything to me, but we can silence it using a SwiftUI technique called CodingKeys. Now by default, Swift will use all properties for coding and decoding, but one thing CodingKeys let us do is to specify which properties we should use for coding and decoding. So if I start typing the word coding just before the closing curly in this struct, you see Xcode offers to enter CodingKeys for me, so I'll press return, and boom! We see what CodingKeys are. They're an enumeration named CodingKeys that conform to the CodingKeys protocol. Xcode takes care of all of that for me, but I want to specify that I only want to use the properties name and URL for decoding. If I do that, that's going to ignore the ID property. So I'm just going to highlight and delete the ID case in this enumeration. I'm going to keep the cases for name and URL, but I can put them on the same line, and we've got no warnings or errors. Now let's head over to our creatures list view and take advantage of our new identifiable struct. So creatures.creatureArray is an array of creature structs. That's the struct that we just conformed to identifiable. And because creatures array is now an array of identifiable structs, we can get rid of this ID property in here. When you iterate through something that's identifiable, you don't need ID. SwiftUI finds that automatically. And because the identifiable ID is unique, we no longer need this \self. So I'm going to highlight through the comma all the way through .self and delete this. Now we also want to make sure we're not iterating through a range of numbers anymore. We want to iterate just through creatures.creaturesArray. So I'm going to delete count, and I'm going to delete the range part in the front here. So it just says list and then creatures.creaturesArray in between parentheses. We also want to get rid of the name index. That's not a good name when we're iterating through an array of creatures. So why don't we just call this creature singular? And now in the destination part of the navigation link, we can pass over that creature. So let's replace what was in there with creature singular. Now, since we're no longer using the index, it's going to be tougher to add a number in front. We'll deal with that in the next lesson. But for now, let's get rid of everything that used to be in the text view. We'll replace it with creature.name.capitalized. And then in the task view below this, we can change creatures.creaturesArray with the index value to just creature. And we see things refresh in the preview, and we can see we can scroll through. Pages are being loaded. We can load all, no problems at all. We just made our creature object identifiable using CodingKeys, but CodingKeys are going to have another benefit that we'll see as we try to get a nicer image for our Pokemon detail. Now if we look at Bulbasaur, cute, but kind of small. I'd prefer an image that were bigger, that had less white space so I could really see the creature. Now there's actually a nicer image that we can use. In order to show you that, I'm going to head over to my browser and get into the first page of JSON, click on Bulbasaur, and I'll collapse everything so that we can see the sprites level, which is where the images are. When I first started using this API years ago, the best image was this front default at the sprites level, but now there's official artwork. So let me find this in here, and you can see we get a larger, higher quality artwork. So how do we get this? Well, inside sprites, then there's a key called other, then there's a key called official-artwork, and finally another key named front_default. But this is a different front_default. But when we try to get this, we're going to run into a problem. When we try to create structures to decode this, do you see the name here, official-artwork? Well, we can't use dashes as Swift variable names. Dashes are considered to be the subtraction symbol, so this won't work. Let's generate that error, but then we'll see how we can use CodingKeys to map a JSON key to a valid Swift property. So let's head back to our creature detail file where our creature detail struct is. We can start to build out our data structure that matches the JSON. So in sprite, we'll need another key. I'll add var lowercase other. Again, this needs to be spelled exactly like the JSON or I'm going to get a JSON error. And I'll follow that with colon, and I'll just call the struct that I'm about to create for this capital O other. Then below this, I'll create that struct with struct capital O other colon codable. Remember, if you're using a struct to decode JSON, it's always got to conform to codable. Open and close curlies. Then I'll head to the web page and I'm going to highlight and copy the key name that I want, official-artwork. But watch what happens when I return to Xcode and try to paste this in. Var paste, and I can already see there's a problem. Xcode is highlighting this in an unusual way. If this was considered to be a variable, it would all be highlighted in this sort of teal color, but it's not. Artwork is in black. If I add colon, and then I'm going to create a struct in here called official artwork in upper camel case, and we've definitely got an error showing up here, but before I deal with that, I'm going to create the last structure. I'll say struct official artwork, upper camel case, conform to codable. In between the curlies, I'll say var front_default colon string. So this is the value I eventually want to get. I want to decode this. It'll be in a string, and this is going to have the URL of the high quality image that I want to use. But how do we fix the problem we have up here where the JSON key isn't a valid Swift variable name? Well, CodingKeys can help here too. Inside the other struct, I'm going to once again enter coding. I can see that Xcode offers CodingKeys for me, so I'll press enter to accept this. And look at what I see here. Xcode thinks that the name is official. So let's change this. I'm going to call this instead, replacing official with official artwork, lower camel case. Then I'm going to set this equal to the string that contains the same troublesome key that's in JSON. So between the double quotes, I'm going to cut out official-artwork up here and paste it between those quotes. Then I'm going to change the variable name to official artwork in lower camel case. But there's one more thing we need to do. Since I'm specifying a raw value here in the enum, I need to add string as the data type right after the colon after the CodingKeys enum name. Don't forget the comma after this. And what this is going to do is that when official-artwork is encountered as a key in the JSON, CodingKeys will pour the data that matches this key in the JSON into the variable named official artwork lower camel case. Now the problem's solved. But I've got to go down and map this new value to my image URL. So down here in the do clause in my getData function, I'm going to delete what I used to set my image URL equal to, and instead I'm going to replace this with returned.sprites.other.officialartwork.front_default. So we set up our CodingKeys and our additional data structure so we can get that higher quality image. Let's head over to creature list view. and take a look at our creature detail and see what we got. And when we click on Bulbasaur, look at that. He's never looked so good. We've got the high quality image in here. We'll check out Ivysaur and Venusaur, and those are all looking great. Now there's another issue that I want to point out. So let's click on Load All, and we see our nice progress view spinning, and I'm going to scroll all the way to the end of my Pokemon. And when we get to the end, I'm going to open up the debug area so we can see the messages printed out to the console. And I'm going to deliberately click on a Pokemon that I know doesn't have an image associated with it. I know this one up here, Corridon, swimming build. Sorry if I've got the Poke pronunciation wrong, but when I click it, down here I see JSON error, could not decode returned JSON data. Now, because we wrote our getData functions in both of our classes to print out the URL that we're accessing when we try to get the JSON, I'm going to copy this URL right here for Pokemon 10266, head over to the browser, and let me paste in this URL, and I'll collapse these triangles so that we can take a look at the sprites. And will you look at that? Every single sprite is null. So in order to deal with this, we need to make sure that sprites other official artwork front_default will decode into not just a string, but a string question mark or an optional value. And we need to deal with that optional value in our getData code. But we know how to do that. Let's head back to Xcode and head over to our creature detail file and make some modifications. So this is pretty straightforward. The problem is when we traverse through sprites, other, official artwork, and front default can potentially return null, which is nil in Swift. Now we can parse that out, but we just need to make sure that the container that we're trying to pour that value into can accept a null or a nil value. So we're just going to change front default down here from being string to string question mark. And that's because this might return null, which is nil in Swift. Now here's another important issue, and this might slip by you, but up here in our sprite structure, we're no longer using this front_default in our app, but our Swift code is still going to try to decode this as part of the JSON. Now if we were going to leave this in, we should set this to a string question mark as well, but since we don't need this value, I'm just going to highlight it and delete it. Now we still got a problem down here in the do portion of our do catch clause and our getData function. When we decode this variable from return sprite other official artwork front default, this could be nil, but we're trying to put it into the string of image URL. So what I'm going to do is just use nil coalescing with question mark after this. And if what we get back in our decoded JSON data is a null or a nil value, I'm just going to pass in a string n/a for not available. Now here's a very important pro tip that could save you a significant amount of time of sleuthing. If you want a URL to register as invalid, do not set nil values to an empty string. Believe it or not, iOS considers an empty string to be a valid URL, and that's because it uses URLs to represent directory paths on a device. So if I passed an empty string in here and I was trying to tell if it was a valid URL or not, which we'll try to do later in this lesson, an empty string is considered a valid URL. So I wouldn't get the result that I wanted. The string NA in here that I've added is not a valid URL, so that's a much better choice. Again, in short, if you want something to represent an invalid URL because it's a nil value, don't pass in an empty string. Then let's head back over to our creatures list view. I'll open up the debug console just so that we can see values printing out down below. Let's check out to make sure that Bulbasaur still shows up, and he does. We don't get any error. Looking magnificent, Bulby. But then I'm going to click on Load All, and I'm going to scroll all the way up until I'm at the last page of my Pokemon. And again, we can click on this very last guy in here, and we do get a proper image. But if we go up here to our swimming guy, Corridon swimming build, click that, well, we get nothing to show up inside of our image, and that's expected. But also, fortunately, we no longer get our error down in our output. Now again, the JSON error that we had wasn't crashing our program, but it's nice that we're not showing an error. Even better, if we can't get back an image, why don't we show a system image in place? How about that dashed rectangle with the question mark inside? We can do it. Let's head over to our detail view and make this happen. I'll show you how. Now, if we look at our async image, we're currently dealing with two conditions. Either we have a valid image to display, in which case our image view is in this image variable that we modify below, or if we don't have any image to show, we use this placeholder, which we're just showing as a round rectangle that's clear, so we really don't show anything. But now we want to deal with three conditions. We might have downloaded a valid image, so we'll display that. We want to display a placeholder while the image loads, but if we get an error, we want to display an image that indicates image not found or image not available. Well, to do this, iOS has a special version of AsyncImage that will treat those 3 separate conditions as what it calls phases. So let's enter this new version of AsyncImage above our current version. First, I'm going to highlight the old version and Command/ to comment everything out. I'm going to want to raid this code when we create our new AsyncImage, and then we'll create our new AsyncImage above. So enter AsyncImage, and now before when we entered an AsyncImage, we selected this option with placeholder. But now I want you to select this option with URL and content. Scale and transaction are grayed out, those are optional. Now if you notice, in code completion it mentions AsyncImage phase here. So this is what's going to let us respond to the phase of image downloading. Either we get an image, we're downloading, or we generated an error. So press return to accept this, and in this first part where it wants a URL, well, we can grab that code from the old AsyncImage that we commented out below. So highlight from URL through the first closing parenthesis right after image URL. Make sure you don't get that extra one, and we'll paste that up in the URL area above. Then tab over to comment, and look, this wants something called an AsyncImage phase, but we can press return on this. We've got to give a name to that AsyncImage phase. Let's just call it phase. Then we'll tab over and we'll write our code. Now, if we get an image, the phase has an image property. So what we'll do is we'll try to see if we can get that as a non-nil value by saying if let, we'll call our image image and set this equal to phase.image, open and close curlies. So if this works, we didn't generate nil, we have a valid image. Otherwise, down below, after the closing curly, we'll say else if phase.error, exclamation point equals, meaning not equals, nil, open and close curlies. If that happens, we've got an error. That'd mean the JSON for this URL returned null, which we processed as nil, and which we turned into that string n/a. And we get that as an error because NA is not a valid URL. Otherwise, the third option is going to be else, open and close curlies. This is where we use a placeholder because our image is still loading. Now, if we've got a valid image, well, let's just go down here to our commented out async image, and we can highlight the image value along with all of its modifiers. Copy it out, paste it up above in the if let image equals phase.image. Make sure it's highlighted and Command/ again to remove those comments, and type Control-I to fix the indentation, and Bulbasaur is back. Although we need to add a frame at the end of async image to fix its size. Now let's head down and grab the placeholder. So that's our rounded rectangle with a foreground style of clear. Copy that, paste it above in our third condition, the else condition, and Command/ on those 2 lines to uncomment them, and highlight them, and Control-I to fix the indentation. Looking good. And so that we fix the size, let's head down to that old async image that's commented out and copy the 2 modifiers at the end, the frame and the padding trailing. Paste them below the closing curly in the async image above, and remove the comments and fix the indentation. Bulbasaur's back to his normal size, so now we can highlight and delete all this commented out code that was the old async image. But we've got this last condition to deal with, the error phase. So if we generate an error, I want to call image and pass in a system name, and in between the double quotes here, let's figure out what image we want. So why don't we head up to the library, the plus symbol, and with the symbols tab clicked, I'm going to search on question mark, one word, and I'm going to scroll until I find one that I like. You can certainly use whichever image you'd like, but I like this one with the dashed lines around it. That's question mark dot square dot dashed, so I'll double click on that, and it goes in the string. Nice. Now I also want to add a bunch of modifiers to the bottom of that system image that I created, so I'm just going to copy all of the modifiers that are below the image above this, and then paste them below the image with the system name question mark square dashed. Now this should work. To check it out, we can head back to our creature list view. I'll adjust the preview. Why don't we load all of our creatures? And I'll speed this up as I scroll all the way to the bottom again. Click on his bottom guy. He shows up. That's great. But let's click on our troublesome one. That's Corydon swimming build. And look at that. While before we were generating a blank space in here, now we see our dashed question mark. Looking good. And toward the end here, there are a few more creatures that don't have any image. But when we click on a creature that has a valid image, looking good. Now what we're currently doing with placeholder is when the image is loading, we're showing a clear rectangle. But why don't we change that to a progress view, that little spinner that we learned about in a prior lesson. Let's head back to the detail view, and in the else clause of our async image with the phases, why don't we highlight the rounded rectangle and its modifier, Command/ to comment it out, and below this I'll add a progress view with tint of red and scale effect 4. And you can see that really quickly it shows up, but it's a nice effect. If you find that too distracting, you can go back to the clear rectangle, but if you like the progress view, why don't you leave it? I like the progress view, so I'm going to delete that clear rectangle that I commented out. And as an additional step, since our async image is so large and contains so much code, I'm going to refactor this out as a variable in an extension. And we learned how to do this in an earlier app that we built when we covered SwiftUI extensions. We don't have to do this, but I think it'll make our code a little bit easier to read. It'll be better organized. So I'm going to code fold my entire async image. Then I'm going to highlight it and cut it out with a Command X. Then I'll head down just after the closing curly in our detail view and just before the preview provider. I'm going to enter my extension. Remember, we say extension, and the name is going to be the current struct that we're extending, which is detail view. Open and close curlies, and then we'll create a variable to hold the view code for the async image. So I'm going to call this var creature image, lower camel case. And remember, we've got to say :sum capital V view, open and close curlies, then paste in the async image code. And so our extension just created a variable named creature image, which is a view which contains all of our async image code. So every time we mention creature image spelled in lower camel case, that view will appear. Now it's only showing in one place, but I'm going to write it right in here. Creature image, lower camel case. This is a variable, so I don't need curlies. And look at that, Bulbasaur is back. And this just makes my code easier to read because I can see everything that's in the H stack, the creature image, and then this V stack. I don't have this huge async image encode that makes it harder to kind of browse through my code and see what's going on. Again, just a nicer way to more professionally organize your code. And remember, if you ever need to quickly get to a function definition or a term that you've defined, you can just right-click on it and then select Jump to Definition from the Quick Action menu. And there we are down in our extension. Nice. And again, if we head back to Creatures List View, you can see that we can click on various different Pokemon, and we can see the image looks great. We've now got a little progress view swirling while the image loads. If you load them all and scroll to the end, and we find any of those creatures that don't have a valid image, we can see that our system image is showing up. If we don't have any image available, we get the null value. So once again, big learning was afoot. We learned about coding keys, identifiable in the ID property, dealing with null values returned from JSON, and async image phases. Plus, we added a progress view while an image was loading. Nice work, PokeTraining programmer. There's more goodness in this app to come as we learn to search on Pokemon next. Be sure to come back for more goodness while we continue to hack.